Section 6 of Chapter 4 is the section that I've been telling you about that existed. There are imaginary numbers. I did not lie to you. This chapter is titled Complex Numbers. We're going to start out with the imaginary unit of I. The imaginary unit of I stands for the square root of -1. And that's why it's called imaginary, because you can't take the square root of a negative number because there's nothing times itself that equals negative. Because if you take two numbers and multiply them by each other, they will always equal a positive. So the square root of a -1, we're just going to call I. And so what that looks like in real numbers is if you have the square root of a -3, that's the same as the square root of a -1 times 3. And so the way you're going to show this is, well, the square root of -1 is I, and then you just have the square root of 3 is still the square root of 3. So this is what that would look like when you're simplifying it. If you square an I, the I squared is going to be the square root of -1 times the square root of -1. And the square root of anything squared is itself. So the square root of -1 times the square root of -1 is simply -1. And the square root of 3 squared is 3. So if you take I times the square root of 3 and square the whole thing, your answer is simply -3. So put over here make sure that you have notes in your notes next to imaginary unit. So I is the square root of -1. So I squared, anywhere you have an I squared, your answer is going to be -1. So to simplify it all the way down, you're going to have -1. So what that's going to look like in a problem, if you're trying to solve something like this, you can't factor it because there's no x term. So let's just get the x squared term by itself and take the square root. So subtract 18 from both sides. So 2x squared equals -90. Divide both sides by 2. So x squared equals a -45. Well, that's easy. X squared, all I have to do to undo that is take the square root of that. But now is when I have, the square root of a -45. So x equals plus or minus, don't forget that if we have the square root, remember you have two answers, because either it's going to be the negative answer squared or the positive answer squared. So plus or minus the square root of -1 times, I'm going to split this up into 9 times 5. 9 times 5 is 45, and I happen to know the square root of 9 is 3. So these two items can come out of my square root box because the square root of -1 is I, and the square root of 9 is 3. So that would look like plus or minus 3i times the square root of 5. So that's what your final answer will look like there. Try this one on your own, pause it, try it on your own, and then come back, and I'll do it with you. Did you pause? Did you do it? Let me see. All right. So on this one, you're going to get the x squared by itself, so subtract 11 from both sides. So x squared equals -8. X squared is easy. Plus or minus the square root. So x equals plus or minus the square root of -1 times, I'm going to make it 4 times 2, because I happen to know that the square root of 4 is 2. So now x equals plus or minus 2i times the square root of 2, because that part can't come out. It's still a square root that can't come out of the box. So it has to stay in. So do you see where the 2 comes from? Square root of 4 is 2. Square root of -1 is I. Don't forget that your answer could either be positive or negative. Do numbers 1, 3, and 5 of those guided practice real quick. Pause and do them, and then come back. And I hope you did it, because now I'm going to actually just give you the answers instead of working them all the way through. So hopefully, number 1, 3, and 5, these should be the answers that you got. So if you didn't, you need to go back and you need to figure out, oh dear, what did I do wrong? All right? So figure those out now. Make sure you understand that part. And then we'll move on to complex numbers. All right, the complex numbers. Complex numbers just combine real numbers and imaginary numbers. So that says A plus BI, where A is your real number and BI is your imaginary number. All right, so we've got a real number and imaginary number. And when we combine them and work with them and do things with these complex numbers, you've already learned how to use, I can't write and talk at the same time, obviously. How to use, how to work with binomials. So these are going to be just like working with binomials until we square them, and then you're going to have to remember that, oh, this isn't just I squared. You're never going to have an I squared in your final answer. So let's do a couple of these. Are you writing them down too? Get them written down and we'll do them together. All right. So with these complex numbers, this is what's called the standard form, where we put the real number first and then add it or subtract it from the imaginary number. And that imaginary number, that I, can have a coefficient in front of it. So 12 minus 11i is an imaginary or a complex number. Negative 8 plus 3i is also a complex number. If we're going to put those together, we want to combine the like terms, so to speak, and then I want to put it into standard form. You always want your answer to be real number plus an imaginary number. So let's just combine them. 12 minus 8 is 4, and we don't change the sign because we're adding. And then negative 11i plus 3i is going to be a negative 8i because the 11 is bigger. And so this actually was that quick and easy. We're finished. With this one, go ahead and pause it and see if you can do it yourself, making sure that you be careful of the negative. All right? So now that you paused and you did it, now you're going to look, you're going to have the 15 minus 24 is going to be a negative 9. And now be careful here because you've got a negative 9i minus a negative makes that plus. So negative 9i plus 9i will drop out. So negative 9 is your final answer. So combining those like terms, adding and subtracting should be fairly simple. Just make sure that you combine those like terms. There's some more guided practice problems. If you would like to try some more on page 276. And then we're going to move on to multiplying and dividing. So with multiplying, it's again just like your using your binomials. When you multiply, you're either going to distribute or use FOIL, depending on if you're multiplying by just the real number or just the imaginary number or a whole complex number. So it looks like this. Negative 5i times 8 minus 9i. And we have room. We'll do one more here. Negative 8 plus 2i times 4 minus 7i. Yes. Okay. So when we multiply these, on this one, we're just multiplying by an imaginary number, not a complex number. So we simply distribute. This negative 5i needs to be multiplied throughout the binomial here. So negative 5i times 8 is a negative 40i. And then negative 5i times a negative 9i. Negative times a negative is a positive. 5 times 9 is 45. I times I is I squared. Now remember, your I squared equals negative 1. So this 45 becomes a negative 45. And to put it into standard form, the real number has to come first. So negative 45 minus 40i is your final answer in standard form. So once you have a squared I, it becomes a -1, and then that term becomes real, and that has to bump to the front of your complex number. Let's use one that uses FOIL. -8 times 4 is -32. -8 times -7 is a +56i. 2 times 4 is 8i. And positive times a negative is going to be a -14i squared. All right? So in this one, your I squared, remember, is -1, which makes this a +14. So the +14 and the -32 need to be combined for a -18. Is that right? 8, 9, 10, 11, 12. Yes. Okay. -18. And then you combine your I terms, which is going to be a +64i. And I have a real number plus an imaginary number. That is standard form, and I'm finished. Try some more of those. Make sure you've got those under your belt before we move on to divide. When we divide, we've got to remember that in our denominator of our fraction, when we divide, we often just leave it as a fraction. In our denominator, remember, we can never have a square root in the denominator of a fraction, and I is the same as the square root of a -1. So we can never have an imaginary number in our denominator. So in order to get rid of that, we're going to use what's called the complex conjugate. And I will show you where to put that as soon as I drop everything onto the floor. All right, let's get some problems. Whew. All right. 3 plus 4i over 5 minus i. So I can't have an I in my denominator. And if I multiply by I times I is a -1, and that works well. But then all of a sudden I have a 5i because I have to multiply it by everything. So the trick is, if you'll remember back to when you did the perfect square minus the perfect square, that same type of thing is going to come into play here, because the conjugate of a plus bi is going to be a minus bi. So you have a positive I in one and a negative I in the other, and what happens when you do that is those middle terms drop out. So I'm going to use the conjugate of 5 minus I and multiply the conjugate of my denominator. So keep the same terms, 5 and I, and I have a different sign. This one is negative, so this one is going to be positive. And when I do that, my 5 times 5 is 25, and my I times I is I squared, which is just -1. So 5 times 5 is your 25, and why is this not right? It's minus a -1. That's why I'm all confused. Minus a -1, and so because these two are different, so it's minus the I squared. So minus a negative I squared is a positive one because it's minus a negative. Whoo boy, all confusing. All right, but then the 5 times I is 5i, and negative I times 5 is 5i is 5i minus 5i. So that's why those middle terms drop out, which is what you want, because now we don't have an I in our denominator, and this just becomes 26 in our denominator. But remember, whatever we multiply in the denominator, we must multiply in the numerator, and that's easy enough. 3 times 5 is 15, and 3i, and 20i, and 4i squared, plus 4i squared, which is just -1. So now, oh dear, let's move this down. All right, so now I've got 26 in my denominator. And then I've got to combine your 15 and a -4, because it was plus 4 times a -1. So 15 minus 4 is 11. and 3i and 20i are 23i. All right, and so now to put this into standard form, we need to have a real number plus an imaginary number. So we're simply going to split this up into two fractions. So we have 11/26 plus 23/26i. Sorry, squishy. All right. So that puts that into standard form, to have two fractions added together as standard form instead of having the complex number divided by a number. All right. Holy macaroni. Two more things really quick. Can your brain handle it? The next thing we're going to do is we're going to graph complex numbers. And as confusing as that sounds, it's really, really simple because we're going to simply use a complex plane. When we use the complex plane, we're going to call this axis the real axis, and this one is the imaginary. So if we want to graph, say, 4 plus 2i, all you're going to do is you're going to graph the 4 on the real plane. So you're going to go to the right 4, 1, 2, 3, 4, and 2i is going to be up 2 because you're going to go up on the imaginary plane. So there's your point. Got it? Got it? Got it? So graph these real quick, and then I'll do them, and let's see if we get the same thing. Did you pause and graph them, or are you doing it really quick while I'm talking? All right, so -1 plus 3i, you're going to go 1 to the left on the real plane, and then up 3. There's a point. Really simple. -4i, you don't move off of the real plane. You're going to go down 4 on the imaginary plane. 2 minus 2i, positive 2, and then down 2 because on the imaginary plane, and so there's your points. All right, if you're still not getting that, look at the guided practice. Go back and look again. It's really simple. Real and imaginary. All right, once you can catch on to those, it's really, really simple. Last thing is absolute value. Absolute value of complex numbers is simply the square root of a squared plus b squared. So once you remember that formula, you just plug in the numbers. So the absolute value of 5 minus 12i So the absolute value of 5 minus 12i is simply going to be the square root of 5 squared, 5 is your a, plus b squared, which is 12i squared. So did you see where I got that? A is your real number, b is your imaginary number, and so when you do that, when you multiply those, 5 squared is 25. The 12i squared becomes 144. And the square root of that, oh, we have to add them together, huh? So, I lost my negative. Negative 12. And so it's just the b, not the imaginary number. It's just the b itself. So 5 squared plus the negative 12 squared is your 144. When you add those together, you get 169. And the square root of 169 is simply 13. And so your absolute value is 13. And what you're doing there is you're finding the distance from, let's see, 5, 1, 2, 3, 4, 5. Oh, I can't go 12 up. 1, 2, 3, 4, 5, 10, 11, 12. You're finding the distance from here to here when you're finding the absolute value It's the distance. Remember, the absolute value is a distance. And so when you square each of those terms and then get the square root of that, you're finding the distance from that point to the origin. So one more. The absolute value of 17i. Well, the absolute value of 17i is simply going to be the square root of a squared plus b squared. We don't have an a term, so just leave it blank. The b squared is 17 squared. And the square root of 17 squared is simply 17. So, all of that to say, that is a ton of stuff. Each small thing isn't very difficult. It's simply a matter of remembering each part. So I hope you took great notes, and I will see you in class, and we'll work through each section and make sure you've got each one. See you later.